All right, problem number 1. We start off with this given information right up here at the top. So I'm going to go and mark that on the picture. It says angle ABC, ABC, that's this angle right here. And angle ABD, ABD, that's this angle right over here, are congruent. So that's the first piece of given information. The second piece of given information is angle CAB, CAB. Oh, thank you. Angle CAB. There we go. And angle DAB, DAB. So this angle over here are congruent. These are the two pieces of given information. What other piece of information do you know from the picture, which is to say, what is it that we are allowed to mark up even though it wasn't part of the given information? Shared side. So we're going to write up here. What is the name of that shared side? Thank you, Sally. AB. So we're going to say AB is congruent to AB, and I'm going to mark it on the picture. There's my little congruence mark. Write a congruence statement for the two triangles. So first triangle we can name any way we want to. The one that I'm shading in yellow right now, give me one way to name that triangle. CBA is the first thing I heard. CBA. Order on the first triangle does not matter. But then, when we go to write the name of the second triangle, we have to make sure to match up the corresponding congruent pieces. So, angle C on the yellow triangle is the only angle that doesn't have a congruence mark on it. What does that correspond to on the other triangle? D. So I would start this with D. And then the first triangle then goes to B, which has this blue arc marking on it. On the white triangle, that would correspond to B. And then finally we have A, which has this arc marking with a slash on it. What does that correspond to on the other triangle? A, yes. So triangle CBA is congruent to triangle DBA. Next part down, name the postulate or theorem used. So when we're talking about the postulate or theorem that is being used, when showing two triangles are congruent, my choices are side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse leg. Which one of those is being used in this picture right now? Angle, side, angle. So we're going to do A, S, A. For angle, angle, side, name the additional part needed. So for angle, angle, side, here's my side that has a congruence mark on it. Here's one of the angles that's marked. Oh, come on. There we go. There's one of my angles that's marked. Angle, side, angle has both sides of the line segment with marked angles. Angle, angle, side has an angle that does not touch my side. So which pair of angles would I have to say is congruent if I wanted to use angle, angle, side? Angle C is congruent to angle D, yes. Angle C is congruent to angle D. Why could we call them angles C and D for that last part, but up in the given information they had to give me a 3-letter name for the angles? Yeah, when I have a shared side that is splitting my two triangles apart, I have to give a 3-letter name for any angles that touch that shared side, because otherwise it's not clear whether I'm talking about the left-hand angle or the right-hand angle. So you have to give it a 3-letter name whenever we have a shared side and the angle that we're talking about touches that shared side. What else would you guys like to go over? You said number 4? Absolutely. Let's go look at number 4. Problem number 4, using the picture, find the angles. All right, so this is going to be really important for tomorrow. Really important for the test tomorrow. This top angle, BDC, BDC, that is an outside angle. We call that an exterior angle. The 2 angles on the inside of the triangle that do not touch that exterior angle are called remote interior angles. We learned right back at the beginning of this module that these 2 remote interior angles add together to give you the exterior angle. So the way we find the measurement of angle BDC is we're going to do 37 degrees plus 42 degrees. What is 37 plus 42? 79. So I would have 79 degrees. Come on. Sorry guys, my software has been messing up. So let me try to get it back to this. There we go. These are my remote, oh my goodness, remote interior angles. There we go. The remote interior angles add up to that exterior angle. Please, 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 please make yourself notes about that. Make a flashcard, write a big note on your test review, highlight it, whatever you need to do so that you remember this exterior angle theorem, that the 2 remote interior angles add up to give me that exterior angle. All right, so we said the exterior angle is 79 degrees. So I'm going to add that to my picture right here. We also want the measurement of angle BDA. Angle BDA is this angle over here. What's the name for this pair of angles right here? Linear pair. And what do linear pair angles add up to? 180. So I could say the measurement of angle BDA plus 79 degrees equals 180. And then I can subtract 79 from both sides. What is 180 minus 79? 101. Measurement of angle BDA is 101 degrees. Nicely done. Could there have been another way to answer that last question to get this 101 degrees for right here? How else could you do that? Yes. These 3 angles, the 3 inside the triangle, always add up to what? 180. So you can add these 2 together and subtract it from 180. Look, that's exactly what we did when we used our linear pair, though, because my exterior angle is these 2 added together. And then I minused it from 180 to get that inside angle. All right. What else would you guys like to see? 11? Absolutely. Let's go look at problem number 11. Oops, one too far. Problem number 11. In the diagram shown, find x and y. All right, so to find x, I have an x here, an x here, come on, and an x here. Let me get it to the right screen now. Come on. Sorry guys, I don't know why it's messing up like this. There, nope, it was working for a second. There we go. Got number 11 up. I have x's in these 3 spots. Can we add the sides of a triangle together? Can we add the sides of a triangle together? Never, ever, 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 ever add the sides of a triangle together. The sides of a triangle do not add up to anything in particular. I can have tiny triangles. I can have huge triangles. The sides are going to add up to different things. It's the angles that always add up to 180, not the sides. Never, ever, 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 ever add the sides of a triangle together. The only thing I can ever do with the sides of a triangle is figure out if there's 2 of them that are the same size. And if I have 2 sides that are the same size, I don't add them. I can set them equal to each other. But I don't know which ones of these are equal. And they're not necessarily all the same size. So I can't set all 3 equal to each other. So I'm stuck on x right now. But I can go and figure out what y is. Y is right here, which is inside my triangle. I also have this 54-degree angle up at the top. If I knew how big this angle was down here, then I could use my triangle sum theorem. I can add the angles of a triangle together. Yes. Yes. These 2 angles right here form a linear pair. So that means I can do 180 minus the 108 that's outside the triangle. What is 180 minus 108? 72. So this angle right here is 72 degrees. So now I have the 3 angles inside the triangle. So I can use my triangle sum theorem. We're going to add those 3 angles together. I'm going to add y plus 54. It'll come back up. Plus 72. And equal that to 180. I can combine my 2 like terms together, 54 and 72. What do you get when you add 54 and 72? 126. So y plus 126 equals 180. And then I minus 126 from both sides. We get what? 54. So y degrees equals 54 degrees. So I'm going to circle that. I'm going to write it on the line. Y is 54. And I'm even going to come over here and add it to my picture. This is, I don't need to mark that out, I suppose. This is 54 degrees right here. Do I have more than one angle that is the same size? Yes, y is the same size as my top angle, which means this is what kind of triangle? If I have two angles that are the same size, it's an isosceles triangle. Isosceles triangles don't just have two angles that are the same size. They also have what? Two sides that are the same size. We go across from the angles. What is across from this 54-degree angle? Yes, 7x minus 14. So this side down here is one of my congruent sides, so I'm going to underline it. What is the other side that would be congruent to that? 2x plus 16. Opposite this angle is the other side that is congruent, so right here. So I can take 7x minus 14 and set it equal to 2x plus 16. You will get a very different answer if you set these two sides equal to each other, or if you set these two sides equal to each other. Please make sure you pick out the correct two sides, the ones that are congruent, that are opposite our congruent angles, to find x. So then I get my x's to the same side. I minus 2x from both sides. That gives me 5x minus 14 equals 16. Then I add 14 to both sides. What's 16 plus 14? 30. 5 times what gives me 30? 6. So x is 6. One of the things that I definitely want you to keep in mind going into the test tomorrow is that if I ask you to find x and y, or I ask you to find a and b, you won't always be able to find the first letter that I asked for first. Like on this one, we had to find y first so that we knew how to set up to find x. That is not uncommon on these problems. Yes. What else would you guys like to see? $18? Absolutely. Let's go look at 18. One too far again. All right, problem number 18. Which one does not prove the triangle's congruent? All right, so I'm going to start off, before I start looking at my options, is there anything that I'm allowed to mark on this triangle even though it might not be over here? Shared side, yes. So AH, I'm going to go ahead and mark that as congruent. I am always allowed to mark that on any problems ever, even if the directions don't mention something like that. You can always mark shared sides and vertical angles as being congruent. All right, so let's look at option A. And remember, we are looking for the option that says they are not, like it's not enough to say that they are congruent. All right, I have angle MAH, so that's this angle up here, is congruent to angle TAH, so that's the other little top angle. So it's saying these two little top angles are congruent. And then angle AHM, so this angle is congruent to AHT, so this angle over here. If I have a triangle marked up like this, what could I use to say the two triangles are congruent? I could use angle side angle. Is angle side angle an okay way to show two triangles congruent? Yes. So I'm going to throw that option out because this one does work, and I want the one that does not work. All right, I'm going to erase those angle markings. I'm still going to keep my shared side marking. And I'm going to go look at B now, and I'm going to mark things up according to B. It says angle M is congruent to angle T. Angle M is congruent to angle T. Angle AHM, that was this one that we marked a moment ago, is congruent to AHT, this one here. Do I have enough marked up in the picture to say that the two triangles are congruent? Yes. What's been marked? Angle, angle, side, or side, angle, angle. Angle, angle, side, or side, angle, angle. Is that acceptable? Yes. Okay, so we're going to throw that one out. So I'm going to erase my angle markings again, and we're going to go look at option C now. Segment MH, that's this one down here, is congruent to segment TH, that's this one right here. And angle T is congruent to angle M. What do we have marked up? Angle, side, side, or side, side, angle, right? I'm going to write down side, side, angle, because that one I won't get in trouble for writing down at school. Is that an okay way to show that two triangles are congruent? No. So we found our answer. This one right here, because angle, side, side, or side, side, angle does not work. I want to look briefly at the bottom one just so we know why that one does work. But we're just going to look at it very briefly. It says angle AHM is 90. So I would have a right angle marking here. Angle AHT is also 90. So that would be a right angle marking here. And segment AM, right here, is congruent to segment AT, right here. If I have this right angle marking in the corner, what kind of triangle do we call it? Yes, that's what we will use. If it has a right angle marking, then it is a right triangle. Hold on, let me get it back to the correct screen. Come on. But if it's got that right angle marking, then it is a right angle. And that means we could use hypotenuse leg if we have the hypotenuse and a corresponding leg. $17? Absolutely. As soon as I can get it to the correct screen that is projecting. Give me just a second. Right, name, date, and time. Come on. Guys, I apologize so much. I was messing with this morning, seeing if I couldn't get it to work. And I was not having a lot of luck. All right. So opposite the right angle, that's what we call the hypotenuse. And that's what we have on both of these over here. And then the other side that's marked, this side right here, if it's not the hypotenuse on a right triangle, then we call it a leg. So we could use hypotenuse leg on this one.
If it's a right angle and it's not across, then it's just like angle something.
Yeah, if we have a right angle, but I don't have the side marked that is across from that right angle, then we could do angle, side, angle. But you can't use hypotenuse leg unless you have the side that is opposite that right angle there. All right, 17. Given triangle AWE and a triangle SOM, fill in the table below and answer the questions. So we want the corresponding angles first. So I'm going to match up one letter to one letter, same position. So A would be an angle of a triangle. So I'd say angle A is congruent to, what would that correspond to on the other triangle? Angle S, yes, first letter to first letter. And then what else could I match up? W and O. Angle W is the second letter, angle O is the second letter. And finally, for my angles, I could also match up what? E and M. Angle E congruent to angle M. Perfect. So that's my corresponding angles. First one to first one, middle one to middle one, third one to third one. For my sides, perfect, yes. For my sides, we have to do 2 letters. So I still need to be looking at position. So first 2 letters on the first triangle name would be AW, and I'm going to put a segment notation over the top, is congruent to, and then I want the first 2 letters over here, which would be SO. So AW is congruent to SO. What's another pair of sides that I could match up? WE, last 2 letters, and OM, last 2 letters. So segment WE is congruent to segment OM. And finally, we can match up what for our third side? AE, first and last letter. Segment AE is congruent to, and then we do first and last letter here, SM. What is the reason that these parts are congruent? They're giving us a little hint here. Parts. Yes, you're absolutely right. What kind of parts do we call these when we match them up? Corresponding. These are corresponding parts, yep, of congruent triangles. And so that means they are congruent. CP, CTC is the reason that these parts are congruent. If they're ever asking you about congruent parts, especially if they use those words like they did right here, they're giving you a big hint as to what this is. All right, we've got about 11 minutes left. That's somewhere between 2 and 3 questions, depending on how long the questions take. Yes. 20? Absolutely. Let's go look at number 20. We have a proof here on number 20.